Hello guys, welcome back to a new lesson. This lesson is for NumPy. As you know, NumPy is a powerful library for dealing with arrays. I think before starting with NumPy, it is very important to make clear what is an array. Let's see a representation. This is a representation of an array. An array contains different kinds of values, for example, numbers such as integers or floats, strings. Each value is stored in a memory position. In this graphic, each square represents a memory position, a place where this value is stored. The reference of each position is an index. So, in an array, we have two values, the value of the content and the value of the index. The index represents the position of each value. The first index number always is 0. Any array index starts in 0. In this case, the array length is 6, so the last index is 5 because I'm starting in 0. The final index will be the array length minus 1. If I need to visualize or to extract the content of any value, I need to specify the position where is located this value. This element AB, it is at the position 4. It's very important to note the first index, the 0 index. Okay, this is a representation of an array in one dimension, but I can have more dimensions. Let's check this concept. If I have one dimension, I have 1D array. So this array will have an axis. The representation of 1D array is an axis with the number 0. This is a convention, axis 0. And the shape of this array will be 5, an empty value, because I only have one dimension. The first number always represents rows. This is 1D array, but I can have a 2D array. 2D array is a matrix with rows and columns. In this case, axis 0 represents rows and axis 1 represents the columns. So this point 2, 3 represents the intersection of the row 2 with the column 3. Remember, the first value is always about rows and the second value is about columns. So the shape will be 5 by 5, 5 rows with 5 columns in two axes, axis 0 and axis 1. This notation is very important to know when you are creating arrays with NumPy. Now let's see a case with 3D array. This is a 3D array. 3 dimensions. The axis 0 for the rows, axis 1 for the columns, and axis 2 in depth. The shape will be 4 rows by 4 columns and 3 columns in depth. Okay, this is a representation of NumPy array. You can also have more dimensions, but the concept is the same. Now it's time to start with the coding. Please open Jupyter Notebook and find this lesson for NumPy. Okay, if you have successfully run Jupyter, you will have this window. This is a folder for this course. Inside this folder, you will find all chapters. Go to Data Analysis and find NumPy. This is the Jupyter code for all lessons in NumPy. Okay, this is the complete code. You can follow me with this code, but I will create a new one to go step by step. In this lesson, I will cover mathematical operations. The first step is to import NumPy. Import NumPy. And I can use an alias as np. Just run this code. Now I can use NumPy with its alias. Now, if I need to create a title, I can use Markdown selection and I can place some HTML code. This B creates a text in bold. Let's run this. Now, this is the title in bold. How can I create an array? It's very easy. I need to use the function array from NumPy. This is my variable, which is equal to np, it is NumPy. I'm using this function with this notation, with the dot. I'm accessing to the array function with the dot. Inside this parenthesis, I'm entering the values. Let's run this. If I need to get the content of this variable, I need to write the name of the variable. This is an array. In some cases, it's very helpful to create an array of ones, the number 1. So I need to use the function ones from NumPy, np.ones. And inside this parenthesis, these numbers represents the structure of this array. 2 is the number of rows and 3 is the number of columns. This is the type of the numbers, integers. Let's check the content. It is an array, 2 rows with 3 columns. Fill it with ones. Another case is to create an array with random numbers. So in this case, I need to use 2 functions, random and random, and inside this parenthesis, it is the same like in the previous example. I'm specifying the number of rows and the number of columns. Let's see the content. With these functions, I'm creating random numbers between 0 and 1. But I can also create random numbers in a normal distribution. For example, if I have 2 parameters, mu and sigma, that represents the average and standard deviation, with values 2 and 0.5, I can create random numbers with normal distribution using the function random and the normal function, entering these previous values and generating 100 points of data. Let's see the results. I have in one array 100 random values. Now it's time to check the attributes of an array. For example, if I want to check dimensions of an array, I can use, for this example, this variable. I need to use this function ndim, which is present into any array. Let's run this line. Dimensions are 2 because they represent the number of axes. In this case, I have rows and columns, 2 axes. I can also check the shape of an array. I need to use the function shape. Let's run this line. The shape is 3 by 3 because this array has 3 rows by 3 columns. Now, what about the size? I can get the size of an array using this function size. The size is 9. It's the total number of elements. Now, let's check the type of an array. In this case, all values are in integers with 32 bits. Now, let's perform some mathematical operations. I can perform many kinds of operations. Let's start with subtraction. I have 2 arrays, array A and B, with these values, with the same size. I can perform the subtraction for A minus B. Let's see the result. 6 minus 1 is 5, 5 minus 2 is 3, and so on. Now, if I need to squaring an array, it is easy. I need to use double asterisk and the power number. In this case, it's 2, but I can perform with different power numbers. For example, 3. Let's run again. These are the results. I can apply trigonometric functions. For example, I can perform the function sign using this function from NumPy applied to the array B. These are the results. I can also use the cosine function with this function. These are the results. It's very easy. I can also use conditional operations. For example, if I want to check all values greater than 1, I can apply this condition. B is this array. Values greater than 1 are 2, 5, and 10. So the result is true in all cases and false in the first one. Now, if I want to extract unique values from an array, for example, I have this array with many values, but the value 1 is repeated 3 times. So if I want to extract only unique values, I need to use the function unique from NumPy and passing this previous variable. Okay, all of these are unique values ordered ascending. Now let's implement the sum of values in an array. If I want to calculate the sum of values in the axis number 0, so is the sum according to the rows. This array is this. I'm assuming according to the rows, 0 plus 3 plus 6. The result is 9. 1 plus 4 plus 7. The result is 12. 2 plus 5 plus 8. The result is 15. I can perform the same, but taking in consideration the axis 1, which is the columns. I can also calculate the minimum value. I'm specifying the axis 1 in this case. The result is 0, 3, and 6. Let's check it. This is the array. This is one column. Between these two brackets is one column. The minimum value is 0. The minimum value of the next column is 3. And the minimum value of the last column is 6. It is okay. Another function is the accumulative sum. Let's check it. I'm performing this function into a rows. Axis 0. Okay, 0, 1 and 2, 3, 5 and 7, and finally 9, 12 and 15. Let's check it. The first elements are the same. In the next line, I'm assuming 0 plus 3 is 3. 1 plus 4 is 5. 2 plus 5 is 7. Finally, 6 plus 3 plus 0 is 9. 7 plus 4 plus 1 is 12. 8 plus 5 plus 2 is 15. It is okay. It is the same. Very good. Okay, let's finish this lesson with the floor function. It's a round function with a minimum. I have these values. Let's see the results. The floor of the 0.5 is 0. Is the minimum value, the near minimum value, rounding this value. 1.1, the minimum is 1. Minus 1.2, the minimum is minus 2. 5 is 5. And finally, minus 2.0, the minimum, it is the same, minus 2. Okay, there are a lot of functions from NumPy. You can check all functions using the object NumPy, the dot sign, and here press Tab, the Tab key. This window contains all functions. You can check in detail all of them. That is all for now. The next lesson will be for indexing, slicing, and iterating. Until then, enjoy the content. See you soon. Bye bye.